Hello and good day to you. You're once again welcome to MESO Constructions, where we discuss all things engineering and architecture. Today, we'll be learning how to read your Rebar details. Yes, we'll be learning how to read your Rebar details. However, before further ado, if you like our videos, kindly subscribe to our channel to encourage us to keep making videos like this. You can also hit the notification bell to get notifications on our future videos. We will also appreciate you giving our content a like, sharing our content with friends, and leaving a comment in the comment section so that we can interact with you and know what you think and what we can do better. Thank you. Right now, let's get into the video. So now, I'm in my Protastructure details, and then we'll be touching on how to read your reinforcement. So let's pick this particular reinforcement. So you realize that this reinforcement spans from here to here. So it's a top reinforcement that spans through two slabs. The distribution bar. Now, if we consider this reinforcement, you realize that this is designated B2, while this is designated B1, and they are both on the same slab. Now, what this means is that you have this B1 as the main reinforcement, while this B2 is also equally the main reinforcement. They are both main reinforcements. However, this B1 is the main reinforcement bar on the cross section of this slab across the shorter span, while this is the main bar on the cross section of this slab across the longer span. And you see it's designated 3 L is equal to 3750, while L of this one is 3450. 3450 is less than 3750, so that's why you have this B1 being the main reinforcement bar, and it's going to be arranged on the bottom layer, while this B2 is going to be arranged right on top of it. Both are main bars. This 12 means the number of days that we'll be needing to span across this slab, and the white 12 means the diameter of the bar. So in a nutshell, it means that we'll be needing 12 numbers of diameter white 12 of bars to span across this slab. And that also means I will have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements of span across this to this place to this place. So now we go to the next part of the detailing, which is 16. This 16 represents the bar mark, and the bar mark as given can be referenced on the table of quantities and bar bending schedule, which is here. And you see that here you have number, size, quantity, length, total. So now let's go back to the bar mark and try to relate them together. So you have 16 here, so we go to our table and we look for 16. So when you get 16, you realize that you have the 16 here. White 12 is the diameter of the bar. So you have 29 quantities that is required. However, we need just 12 of that 29 here, which means there's somewhere else in this slab that requires whatever is left of that. So, but let's concentrate on this. So we have the 16, we have 29 of that, and we require 16 for that particular part of the slab. So we look at the length again to verify that okay, it's the same thing that we're talking about. So we have the length is as 3750, which is the length across the longer span of the slab. If you remember, the length across the longer part of the slab. So now you have it as 3750, which is the length, which confirms that okay, this is exactly what we are doing. We're going to be arranging this white 12 white 12 across this, and it's going to be sleeping horizontally just like this, as denoted by this black bar. So now you also have, let's look at what else you have. So after this 3750, you have the bending schedule itself, which is the main thing that you need to watch out for. It says we'll be bending it straight, and its length is going to be 3710. The length of the span is actually 3710. The length of the span, which means the length of this span from here to here is 3710. You can recall that the length from here to here, actually, which is the length of the stretch of your bar, is 3750, but the length of the span from here to here, will be 3710. So after you have arranged your bar at 250 spacing, you have this length to 3710. So we can escape that now and go on to our next step, which is 250. This 250 represents the spacing of your bars. Just like we said the other time previously, you are going to be having a spacing of 250 between each bar. So if your first bar is here, you have a spacing of 250 mm, then you replace your second bar, a spacing of 250 mm, place your third bar, a spacing of 250 mm, and on like that. So that's what this 250 represents. And this B2, as we've already touched it before, represents the positioning, the location of your bar. While it is also the main bar, we correct that we already discussed that it is the main bar on the second layer of your slab reinforcement, and it's also going to be arranged. If you click this, you realize that it's going to be arranged horizontally. It's going to be arranged horizontally but arrayed vertically, which means you are placing it like this, but it's going to be in 1 2 3 4 5 till you get to top, and the spacing is going to be 250. We already discussed this. B2, it means that it is actually the second main reinforcement that is on your slab. You have the first main reinforcement, the first main bar that is on your slab, which is B1 across the shorter span. This is B2 across the longer span. So we already discussed also this one is the length of your reinforcement, 3750. So now we have been able to touch on how to interpret your structural rebar details. I hope you're able to learn one or two things in this video tutorial. Thanks for watching, and bye for now.